Dear students, now we will discuss the third order, and we have already find the half-life time for first order reaction and half-life time for the second order reaction. Now in this lecture we will discuss half-life period of third order reaction and graphical representation. Theoretically, how graph will obtain by using these equations we will discuss in this equation. Now we have in previous lecture derived this equation. Okay, now we are interested in the half-life period of third order reaction. For this K3 we will transfer for this side 1 half, that is 1 half means the half-life period is equal to 1 upon 2 K A square upon x 2a minus x upon a square a minus x square. We know that from reactant you obtain the product. At the starting its concentration of at the T is equal to 0, reactant concentrate was the A and it was 0. After some times the X product is converted and you will obtain the A minus X reactant is remained as a reactant. After T1 half, this quantity should be half quantity. Remember, T1 half means your reactant should be remain 1 half. This time is called as the half-life period for this third order reaction or any. If reactant is remain half from the original quantity at that time, that time is called as the half-life period. Okay, after the your reactant will be half, at the when reactant will be half, that time is called as the half-life period. And also it is A by 2, the product is also A by 2. Suppose at the start it was 100, after T1 half it is remain 15. Okay, the quantity remains half and that time is called as the half-life period. If it is 50, your product is also 50. Therefore, at half-life period A by 2 is the reactant concentration as well as A by 2 product concentration. Okay, therefore for A minus X and for X we will use A by 2 and for X we will also use the A by 2. Okay, simply putting the values 1 upon 2 K A square as it is, X is the A by 2, then 2a as it is minus x is again A by 2, then A square A as it is, then A minus x, we have known that A minus x we will use the A by 2, therefore A by 2 square. Okay, all the where x we will put the x as the A by 2, A minus x as A by 2, and A we will put as it is. Okay, when single A is there we will put as it is. 2a we will put as it is. Only when there is 2a minus x we will not use the A by 2, we will just replace the x A by 2. If it is only A minus x, then we will replace this by the A by 2. Okay, by solving this is equal to 1 upon 2 K A square. By solving this we will obtain A by 2. By solving this we will obtain 3a by 2. Okay, this you can solve like that. 2a divide numerator and denominator by 2 minus a by 2, then 4a minus a upon 2. Therefore 4a minus a is 3a upon 2 upon, there is already a square is there, a square into above at the, okay, this a square we remove outside, okay, that a square we previously removed at the outside, a square is, okay, it is not here, remember this, okay. Therefore at the bracket only there is a raised to 4, a raised to 2 upon 4, okay. Remember that a square will previously taken outside, that's why will not written like that. 1 upon 2k a square, here 3a square, 2 into 2 4 upon a square upon 4 becomes is equal to 1 upon 2k a square into 3a square upon 4 into, this will revert 4 a square cancel, 4 and 4 is cancelled. Therefore t1 half will be is equal to 3 2k a square, okay. Therefore half-life period for third order reaction can be calculated by using this equation. When we known that this constant and the initial concentration, we can calculate the half-life period for the third order reaction. This is all about the third order reaction. We derive equation and we have find the half-life period of third order reaction, okay. Now we are interested in how the theoretically graph we will draw by using its equations, okay. For the graphical representation we not use the final equation, okay. We use that equation when at the time derivation we subtract, after integration we subtract final concentration minus initial concentration, that values we used, okay. Therefore for this also we final concentration minus initial concentration, that is the final concentration minus initial concentration, final concentration, okay. This equation we use for the representation of graphical way. For represent a graph, we have to compare this equation with a line equation. Line equation will be y is equal to mx plus c. M is your slope, c is intercept, and that is your x coordinate and the y coordinate, okay. The intercept is the constant one for a reaction. Therefore you know that the initial concentration, you know that A is the initial concentration. When you look these three equations, there is a three terms is there. The first term is the a minus x, okay. Then second is the a is there, and there is the k and t, okay. These three terms you can see here. In this first case a minus x is there and a is there. A minus x, a, kt, a minus x square, a and kt, okay. All these you can see there is a three common terms are there, a minus x and a and kt, okay. The initial concentration A, we know that, okay, we know the initial concentration. Therefore this will be, you manage this equation like this quantity is you put at the C, okay. When you rearrange and at the C, your A quantity will be there, okay. At this quantity will be C, this quantity will be C, and this quantity will be C in this line equation. Remember, okay, for graphical representation, first we think understood that way how to compare this equation with the line equation. Then we said that the initial concentration, we know that therefore the term A should be as constant term, that is intercept term A. In this case, in ln A is the constant, you put this as a C, that is intercept. C means the intercept. Then in this case 1 upon A will be your intercept. In this case 1 upon A square will be your intercept. Okay, so, therefore for now we will discuss on the first order reaction. Okay, first order reaction is the ln, we have the equation A minus X then plus ln A is equal to KT. Okay, this quantity is the quantity, this quantity must be the your at the place of slope. Okay, slope is the constant and C is the why we consider C is the intercept, because initial concentration, for initial concentration C must be used instead of this. Okay, for initial concentration was A, therefore in the place of C the quantities of A will be there. Okay, therefore we rearrange this. Okay, ln A minus X. Okay, we previously said that there are three quantities. This maybe you put as a M, this is you consider as a C, and remaining term will be your Y. Remember Y, and this your the T is your X. Remember that. Like that you manage this equation is equal to KT minus ln A. Therefore by your Y always you put the positive, therefore you make it positive. Ln A minus S, therefore you put it positive. All the values or all the sign will be changed. KT minus ln, it is positive. Okay, this minus will be positive. Okay, then by comparing this equation with Y is equal to mx plus C. Okay, we previously say that Y you always take the which quantity? A minus X quantity. Okay, in this case Y will be A upon A minus X. In this case Y is equal to 1 minus A minus X. Remember that. Your initial concentration is the, you consider the A term, any value of A term in first, ln A in second, 1 upon A in third, 1 upon A square. Remember that. Okay, then this is your Y. When you compare this with this equation, this is your Y, minus K is your slope, T is your X, and this is your C, ln A. Okay, when your slope is negative, then your graph should be inclined. Okay, like that you graph is obtained, and this value, okay, ln A minus X, and this is a T. Okay, therefore your slope will be the minus K. Okay, slope will be the minus K. Okay, y2 minus y1, slope we can calculate y2 minus y1 upon x2 minus x1. By putting this value you can calculate the slope. Okay, the intercept, that is ln A is the intercept. Okay, that is you can write it that ln A, from your reaction start from this, that is ln A, that is your intercept. If your slope is having the negative sign, then your graph is inclined graph, you obtain the inclined graph. If it is positive, you obtain the upper side graph. If it is negative, you obtain the downside graph. Like that graph is obtained for the first order reaction. For second order reaction, you will move this towards like that A minus X, this quantity will be moved towards this, is equal to K2T, that is will be positive 1 upon A. This quantity you will obtain 1 upon AX K2T plus 1 upon A. Okay, by comparing with this quantity will be A, This is your slope, t is your x, and this is your slope, intercept. Okay, we previously said that the quantity a, you should be consider any quantity of a, you should be consider as a intercept, which is not individual a. Okay, you remember individual a consider the intercept. In this ln was the individual, therefore we use as a, in this case a upon a is the individual, but a minus x is not individual, it is along with x, it is along with x, therefore this quantity we consider as a y quantity. Therefore when consider with this, your y quantity will be the this 1 upon a minus x, the your y quantity, t is your like that. Your positive, your sign is the positive, therefore your graph should be the goes towards the upper side, and slope will be like that. Slope is the k2 is your slope, positive, okay, positive slope, therefore your graph will be the upper side. Then this quantity is your intercept is equal to 1 upon a. This graph we predicted for the second order reaction. Okay, firstly we decided which quantity will be which quantity by comparing with the line equation. Okay, then third is we have to predict the graph for the third order reaction. Okay, we have the equation by putting this value to this side, then you will obtain 1 upon a minus x square is equal to twice k3t plus 1 upon a square. This equation we will transfer negative sign to this side, positive will be obtained. Then we have to draw the graph. Okay, at the y, this is the y quantity, we compare with this is your slope, t is your x, and your intercept will be 1 upon a square. Okay, at this side 1 upon a minus x square, and t will be the at the y coordinate. Your slope is here positive, therefore your graph will be the most toward the upper side, that is your slope, and slope is equal to 2k3t, that value you have obtained here. Okay, then the intercept is the 1 upon a square. Okay, by this way we have predicted the graphical way, or how the graph for will be for first order reaction, second order reaction, and the third order reaction. We compare this equation with the line equation. Line equation is the y is equal to mx plus c. C is the intercept, m is your slope. By comparing, we have calculated the graph, how the graph is obtained. This is all about first order reaction, second order reaction, and the third order reaction. Thank you very much for listening this.